Okay, let's start. So, welcome everyone. So, for the past few months, we've been holding these webinars based on the Presence project, which is a European project, which is examining how various different factors influence the sense of presence in virtual reality. So, as you may know, presence is a distinctive feature of virtual reality, the illusion of being in the place which the virtual reality, or in general extended reality, depicts to you, and the illusion that the events that are happening there are really happening. And of course, when you build a virtual reality or extended reality application, there's many different choices that you can make about how this is put together. So, for example, should it have haptics or not have haptics? If it has haptics, which kind of haptics should it have? If you have interactions with virtual humans, how should they be represented? Does it need to be photorealistic or can we have cartoon characters? Similarly, when you represent the self, your own avatar in virtual reality, again, that you interact with other people in online in online meetings, again, how should the self avatar be represented? And how does this influence the illusion of presence? And apart from that is simply how do you even measure presence? How do you assess it? How do you measure it? What kind of analysis do you do? And so on. So these are some of the many questions that this consortium, which mainly consists of companies, but also two universities are involved, Hamburg and the University of Barcelona. So my name is Mel Slater from University of Barcelona, and I'm chairing this meeting today. And first of all, to start off, I'd like each one here to introduce yourself and say what it is that you've been working on within the Presence Consortium. So I'll just do it in the order that I see people here. I see Anna is here, but she's not a panelist. Anna Zappa is here, but she's not a panelist. So maybe you can, uh, Maria, elevate her to be a panelist. So,
Yes, that's good.
okay, great. Thank you. So first, we'll do a round of introductions. Everyone say your name, where you work, and what it is that you're working on mainly in the Presence project. So the idea is that we'll have this panel discussion for about 20, 30 minutes, and then we'll open it to the audience, and you can intervene by either typing questions in the chat or actually come on and talk directly with your video and or with your audio and or video. So first of all,
Hi, my name is Joan Llovera. I work at the Artanin Foundation in Geneva. The Artanin Foundation is a research institute built around the idea, very good know-how about mocap. Here behind you have some examples of projects. And I'm a virtual reality researcher, so I look into different aspects. In this project, I've been exploring how to animate characters with new techniques based on physical actuators, applying forces and torques, and how this may help engage between the virtual characters and the virtual reality users in ways that are more convincing than traditional interactive character animation techniques.
thanks very much, Michael.
Yeah, I'm Michael Wiesing, and I'm a postdoc at the Event Lab in the UB at the University of Barcelona. And my background is in cognitive neuroscience, and in present, I'm here at part of the present evaluation. So our job is basically to test all these technologies that are developed in present and to test if they really improve the VR experience. And for that, we are currently have four running experiments for that. So there's a lot of work going on. It's not easy always to test these different kind of technologies together, but I think we found that a good way.
We'll come back to you on a bit more detail later. Um, Iris,
Yeah, thanks, Mel. Just a small corrections. There's 3 universities in the project. We are the third one, a university in Brussels. We are in the project under the label of the Inter-University Microelectronics Center, because our research group at the university in Brussels is affiliated with IMEC, which is known for its microchips. But our research group focuses on studies on media and innovation for information technology. And within that research group, I am part of the research unit looking at immersive and personalized media and user experiences. So that's also my role in the project. And as IMEC, we also coordinate the work package where all of the human-centered design is happening and thus kind of overarches all the different kinds of evaluations, the presence evaluation, as well as, which is what you are explaining here now, Mel, Michael, and Anna, and the UX, which is done by University of Hamburg. And then we are providing insights in the user requirements and the ethical considerations that users have for using the technology in certain contexts.
Thanks very much. Sorry, I confused EMEC with a company. So Anna.
Hi, I'm Anna Zappa, and I'm a postdoc at University of Barcelona. And we're working more on trying to measure co-presence in virtual reality using EEG, so hyperscanning, so measuring the EEG signal over two or three brains at the same time. Trying to find what we call intersubject correlation, so similarities between the signals across these three brains, to see if if we can indirectly measure co-presence in virtual reality. So that's what we're working on right now with Antonio Rodriguez Fornels, and of course also collaborating with Mijail and Mel's group.
And co-presence is, just in case people don't.
So co-presence is really the feeling of being in the same environment with others. So we're looking at social presence, or you can call it also social. So being in an environment where you're sharing with other people, interacting socially.
Thanks. So I will add to the work at UB, which is ways to measure presence. So of course, presence can be measured with questionnaires, which is okay, but questionnaires are subjective, which is obvious because we're measuring something which is subjective, but they're measured after the event, and also it's quite difficult to analyze presence questionnaire data because it's ordinal. It's not like you can take means and standard deviations, although many do. These kind of questionnaire responses, because like if someone scores 3 on a questionnaire and someone else scores 6, it doesn't mean that their intensity of feeling is double the first one. So they're ordinal. So you've got to use special techniques, which is okay. But what we prefer to do is to use a technique where you can measure presence more or less in real time during their experience. So supposing you're comparing 3 different types of intervention with respect to haptics. So someone in virtual reality touches something and they feel nothing, or they touch something and they may feel, let's say, a vibration by holding a controller and the controller vibrates, or they touch something and they're wearing a glove and the glove gives them real feelings of touch. These are just like 3 examples. So during the course of the experience, they're offered possibility to swap between these three different types of haptics. And similarly with avatars, they may have like a very simple avatar, a more complex one which doesn't look like them, or one which is super realistic and actually looks like them. Which one do they prefer? So again, during the course of this scenario, they can switch. They're offered the chance to switch between these different possibilities, and which one do they end up choosing. So underneath all of these different, you might have like 5 different factors like this: avatars, haptics, illumination of the environment, maybe in different forms and so on. So underneath all this, there's a reinforcement learning agent which proposes changes to the user, and the user can accept or reject those changes. So over time, the reinforcement learning agent learns the set of settings of each of these factors, which contribute to what people want. In other words, it's learning the ideal score, the ideal setting for that person. And we've never used a questionnaire. All we're asking is what do they prefer, this or that? So this is the kind of method, as well as questionnaires, of course, we don't throw them away. This is the kind of technology that we're developing in this project. Now, I'd like to come back to the panel and ask, in the work that you've done so far, what's the biggest challenge that you met and how have you overcome it? Or maybe you haven't overcome it. And I'll work backwards this time. So Anna, first of all.
Okay, I would say the biggest challenge we met, it's incredibly challenging actually, measuring EEG in VR because we have the challenge of the three VR headsets combining, but also the three EEG combining. And the most challenging, of course, is timing, right? So there's it takes time to render in VR, and with EEG, what we really need is millisecond precise timing. I won't go into the details of how we solve this because
Is everyone see
Mihail would be much
Anna?
better at this, a plugin that solves this problem. Yeah.
We
You
missed
were
part
just
of what you
frozen.
said. You
Oh,
froze.
okay.
Can you just repeat that again?
That the last part was that we solved this timing problem. Basically, Mihail solved it by developing a plugin that predicts the timing and makes it so that we can match the timing of this, so that we know exactly what we're measuring, what the participant is experiencing in VR while we're measuring brain activity. Can you hear me? I think my
Yes.
connection is not great. Okay.
Yes. So in other words, you're able to align the experience with the EEG responses.
Exactly.
And if you don't have that, you can't really do anything.
No, no.
Right. Okay, great. Iris?
Yes, thanks. I have two big challenges because we have two quite different tasks. So we started in the project with inviting possible end users to reflect on that the technologies we're developing within the use cases. And we also did a workshop with the consortium members to come to a first overview of user requirements. User requirements are short summaries of what a user should be able to do with a system or with a technology that clarify for the technical partners what the user needs are in a very concrete way. But even after these initial, I think it was 5 workshops that we did, we had a huge set of user requirements, which we've had that in previous projects. So we anticipated that we would need to prioritize them with the technical partners in the consortium. And so it was quite challenging to find a way that was not too time consuming because there were so many requirements that we already anticipated in the beginning of the project. We figured it would be easier to do this in a quantitative way. But I think we found that that's not necessarily the case. So our initial idea was, instead of doing what we do in other projects, to discuss this in lengthy discussions, lengthy workshops, to prioritize for the project, what do we want to do? We just sent around surveys asking people to prioritize, and we end up with a prioritized list that we can then cut off and say, okay, this is it. And that has proven to be a wrong assumption. So the discussions are still absolutely necessary. And there's no way of cutting them out without jeopardizing working together in a consortium and trying to develop something that is useful for users in specific use case contexts. So that's one challenge that we met that's related to the task that we're doing on providing user requirements. The other challenge is more related to the task where we want to provide ethical guidance. There we noticed that there's a big difference between the subjects that people have brought up depending on the way they test technology. So we did initial workshops also to get responses on values people have within certain use cases, and which ethical concerns they have. And in the first ones where we had technology proxy, so the participants had videos explaining what the technology would be able to do, and they could test the virtual environment, but without the actual technology. So they had no gloves or vests. And we found that they brought up some generic subjects, but once they were wearing the vests and the gloves and they were actually testing the holoportation, um, there were very different topics that have been addressed. So it's a challenge, I think, that we are taking to other projects as well to see how we can, from the beginning of the project, even before we have the concrete technology available for testing, how we can really bridge that gap and get as concretely as possible within these first workshops.
Yes, it's been my own experience that if you like do a survey and you ask people what features should a particular application have, they'll come up with all kinds of ideas, which typically are not very useful. But if you actually give them an example, an actual running example of the system which you're developing, like an early prototype, then they'll tell you this is wrong, we need this, we need that, we need the other. So it's very difficult to get abstract requirements. Just as a matter of interest for people attending, when you said there were far more requirements than you expected, roughly how many were there?
I think we are over 500 at the moment.
Okay.
So there's a lot, but we categorize them. So it's not just one big pile. We actually made categories and we also made different lists for different use cases or for more general requirements. So there's methods to the madness, but there were quite a lot. And luckily there's also quite a lot that you can say, okay, this is not relevant or feasible within the project timeline. But still, it merits discussion.
Okay, thanks. And Michael?
Okay, yeah. Anna talked already about the EEG study, which is probably from all the studies we do the most complex one. Not just because of the timing, but also because we need to synchronize EEG. We have three EEG systems, the three VR headsets, and this runs all at the same time. We encountered a lot of problems like with networking and so on. But part of that, to me, it was to find the right frame to test the different technologies, which are sometimes quite different, like holoportation is completely different from haptics. And how to bring these things together and find a frame how we can test them in an ecologically valid setting. And in the beginning, there was also more the idea to have one overall experiment where we test different things, but over the time we went away a bit from that and separated things. For example, one problem, uh, like when you look at holoportation, which is a super cool technology, but it's really expensive to render at this point. Which means if we include holoportation experiment, we need to also optimize everything down and possibly limit what we can do with the other technology. So we would not be able to test them appropriately here, which was one reason why we need to separate things a little bit. Um, yeah, but this is basically so finding here this frame to how to test these different technologies in an appropriate way. What was the biggest challenge for me, I would say. I cannot hear you.
What do you mean by heliportation?
Holoportation, I
Holoportation,
mean,
I mean, sorry.
yeah.
Holoportation.
What I mean is, so holoportation is you have a video stream of yourself and you make a point cloud with 100,000 of tiny points representing your body. And this is really expensive to render for the computer. So it would really reduce the performance that we have for other things, and this could then limit what we can do, how we can test the other technologies here. This is what I mean. Does it make it clear?
Okay. Yes.
Hi,
Thanks.
Sergi.
Hi. Joanne?
Hi. So our biggest problem has been mainly it's most about software engineering, and so these techniques of character animation work with deep reinforcement learning, and normally they are used in robots or in characters that are made of blobs of like spheres and shapes. And as soon as you apply these techniques to characters that have the typical characters that you use in virtual reality, which have faces and they have more details and textures and they look a bit like humans, the eye becomes much more demanding. So if they shake a bit or they move a bit strange, it completely breaks the feeling of engaging with someone, and also because at Artanim they're really keen on having good quality movement. We've been pushing a lot the trying to get a motion quality with these physics techniques that is as good as with traditional techniques. So this is taking a considerable effort to basically be able to create these characters and these character controllers in a fast, efficient, and reliable way. So that has been probably our biggest challenge. We are getting there, but it's really been a lot of software engineering and trials and combinations of software packages, etc.
Thanks very much. So I'd like to introduce Sergi, who's the project coordinator. Sergi, could you say something about your role in the project and the biggest research challenge you've faced so far, and have you solved it, and whether or not you've solved it, and if so, how? Obviously, you could spend a whole hour on this, but I
No,
just mean a brief.
no. The thing is that every time that we solve something, we reach a new bottleneck. And I think that is the life of the researcher, and you live your life is like that. You're always following something that is very difficult to achieve. But for instance, recently we have managed to go untethered. Recently means this week, and we have managed to stream and render volumetric video from volumetric reconstructions in WebXR. And this is a very relevant jump because like 3 weeks ago, we need big machines. And now with a little bit less of quality, we can go untethered, we can go on WebXR, and that's fantastic. Second big thing that we are achieving is that when we started this project like 2 years ago, basically what we were doing is getting different point clouds from different cameras and calibrating them and putting them together, right? Today, and for all of you guys are going to be in Naval, I hope that you can see that we have three different types of, say, rendering. One is just calibrating and painting different point clouds. So we have improved the calibration last 3 months. So that point cloud looks much nicer. And we have two alternative rendering techniques. One is just point cloud rendering using a depth bias. So you render what you have closer to your eyes. So you don't need to render all the point cloud. So it's cheaper and faster and looks better because you don't see the typical joins that always appear here. And we have implemented a version of these algorithms developed by Google or Microsoft, one of the big companies, called TSDF. It looks nicer. But the current bottleneck that we are going to be solving next month, I hope in the next GA in Hamburg, we are able to show this, is that we use HD color textures from depth cameras. And now when we do the TSDF, they are blurred somehow. The definition is very low. So now we need to go 4K per camera on the color texture. But I don't know if I'm taking too much time. I finished with that. The problem that we have now is that to send all the data to the server, basically we create a very big texture, like of color, depth, mixture of color, depth textures. And we send this to the cloud. But we send this as a single video, a 2D video. Then with FFmpeg, when we compress this, we have a limit of 8K, no 4K resolution. But if what we want to send is 4K or 8K resolution, but if we want to send 4K cameras, two 4K textures per camera, you can only send 2 cameras. So next step that we are going to do is to split all this transmission instead of mixing everything in one texture, sending the different cameras in different channels. And then we'll have the next problem is how we are going to keep the synchronization of all the frames from origin to destination. But we will solve this hopefully in summer.
Okay, just as a matter of interest, in the WebXR, what are you using? 3.js or Babylon or something else? Do you know?
3.js, yes.
Okay.
And we were surprised because we were using the Draco codecs that have been available for a long time and they work well, but we are using also our own video codec and it works well.
Okay, good.
So very happy.
Okay, thanks very much. So I've got a couple of more questions before I open it up a bit more. So
I think you forgot about John, right?
Oh, sorry. Yeah. Who did I miss? Did I miss
John, did
someone?
you already answer that question, or did I just forget about
Yes,
it?
I did answer
Yeah.
it. It
Yeah,
was
yeah,
Oh,
I
about
sorry.
did.
Okay,
software
I was
engineering
thinking.
and getting the
Okay.
animations to look good
Okay, my bad.
enough.
Sorry.
Yeah. Okay. So a European project, I mean, on the one hand, we're all advancing our research and we're contributing to knowledge in general, which may not be usable today, but maybe in a few years' time. But imagine like the end of the project, which is at the end of this year. What do you think others may be able to use that's been developed from this project so that it's not just a contribution to our research and we get more papers and stuff like that, but that others can use? Joanne.
Yeah, so the techniques that we're using cannot be used, could not be used before starting this project in VR. It's basically a headache of software engineering, reinforcement learning. Basically, the practical aspect of what we are doing is that once we are done, I mean, to the best of our efforts, it will not be perfect, but it will be easy for anyone who wants to basically create these physics-based controllers, which basically it's like putting a robot with inertia and collisions and balance in virtual reality. So we'll have characters that have those, and we can explore much better, for example, how people react to obstacles or how do if these characters stumble, and we can also model some aspects of interpersonal behavior, like the fact that we tend to synchronize our movements when we talk to each other. So these things are easier to model in with these kinds of controllers. And in general, if you want characters that react to physical elements in a scene, it's natural. So doing this before we did this software engineering effort was very difficult, and now it's becoming quite easier because all the pieces are assembled. We'll publish the code, tutorials, examples, etc. So this is something that I think is not just for the scientific community, for people developing video games or virtual reality experiences, it can also be useful.
So there's a concrete take home in a sense that others would be able to use in the future. Michael?
Do research, so it's not so much development where people can use something. But one thing that Anna already mentioned is this plugin that we developed for the synchronization between the brain data and what's going on in VR. This is something I worked on this idea already years ago, but at that point I published a paper which was just a proof of principle. Like the implementation was really, it worked, but not user friendly. Like it involved to make my old version working, you need to download a custom version of Unreal Engine and compile it from source. which is quite cumbersome and now we have here just a plugin which you install in Unity, and then there's one line of code, and you get this timestamp that we need, that okay, the moment when something happens on the display is this exact moment, and then you know when to look into the brain data. I think this is the biggest outcome. I mean, it's of course not for normal people, but for scientists, it's super interesting, for neuroscientists especially.
And also, what about the possibility of results from the presence experiments that others can then learn from for the future?
Yeah, obviously that is as well, of course. I was just more thinking about like yeah, products or something like that. But of
Okay,
course,
thanks.
what we learn from all of this, people can read that and use it for their research and build up on that.
Thanks. Iris?
Yeah, I love how we're all stigmatizing researchers as not normal people. For us, I think there's a couple of things that we can share with other researchers, but also with the broader community, with developers. On the one hand, we have, I already talked about a huge set of requirements that we have. We are currently working on a publication and we want to disseminate it widely, so not only in scientific journals, but also broader than that. On several publications identifying interesting topics within those sets of requirements. For example, we know we have different requirements that refer to building trust in XR systems. We have different requirements that refer to how to make sure that people experience something as realistic, which is not only related to technology, but also to the user environment and stuff like that. So I think those will be very interesting to communicate broadly because it will provide a starting point for everyone who is into developing XR experiences and using different multisensory modalities with those XR experiences. And from the ethical perspective, we are also working on a basic set of ethical teams that you can work with as a developer to leaf through them and to see, okay, what is relevant for me. And what is interesting there is that we identify solutions, but not only at the level of technology, things that you can think of that can be altered in the technology itself, but also in how to guide users and how to adjust the environment to ensure that it is, that it feels safe and that it really supports the ethical values that people have in certain contexts.
Thanks very much. Anna?
Yeah, I would say that if we can come up with a really good, I mean, if we can show that there is co-presence and social presence in VR, this would really be a great validation, with neural measures that are indirect, like you said, that don't depend on questionnaires. And if even more, if we could find correlations between questionnaires and these measures, that would be I think, very important step for the field in terms of validating common environments in VR. And then, yeah, scientifically, I think this would be important data to present. I'm trying to think of, we could use, the idea would be, of course, to use these measures to look at different aspects of VR, not just this game playing that we have, but then try to implement the haptics maybe, or different avatars, and try to, find to validate all these different, use EEG in the same way to validate these different measures. So.
Thanks. Yeah, I mean, with questionnaires, as I said, they're okay, but if you find correlations between questionnaires and other measures which are in principle absolutely nothing to do with the questionnaire, like EEG signals, then this is a strong validation that something real is going on underneath. Sergi?
If I can convince Michael that using our technology is going to generate a higher impact on the feeling of presence when at least two people are talking at distance through VR, instead of using like an avatar. Even if you have your VR headset on your head, that's going to be really a huge objective, because if I convince Michael, I think I convince, say, a decent percentage of humanity. So
Very good. The more
that
skeptical side of humanity.
exactly. But
Thanks.
in more practical terms, I'm sure that we are going to end this project with a really good SDK. And we have been testing the SDK for all conferencing. There are a lot of errors. We are going to solve them. There is a lack of documentation. We are going to provide it. And in addition to that, I expect to present you guys physically in the GA 2-3 objects through which we can generate that feeling of presence and put content on the top and make it easy for use. Of course, some things are difficult to deploy at home, some things are easier to deploy at home, but we still have 9 months, right? And I think it's going to be really intense at the end of this process.
Thanks very much. So now, are there any of the panelists who want to bring up something that we've not talked about that you think is important for the attendees to know at this stage? And meanwhile, I throw this open to anybody who wants to make any comment or ask a question, or anyone from the attendees or the panelists. So you can ask either by using the chat or by actually switching on the video and the audio, and you can make a comment. Somebody speaking?
It was me.
No. Okay. Okay. So meanwhile, while you're thinking of that, I have another question, which is, imagine in the wildest dreams, the European Commission said, by the way, we've just come across some more money, and here's another 3 years of money for you. What would you do, Joanne?
So something that I'd like to, because we have focused mainly on body animation, so we can have characters move in different ways and adapt to interactive techniques in different ways. And the group in Hamburg has focused on having characters that talk and combining talking, generating conversations with facial expressions, so that they can also smile or be sad or be angry and things like this. And the way this, I mean, we've made the proof of concept of putting everything together, but it's not really like well integrated, etc. So something I would really like to have the time to do is to put all this together, look at it carefully to make sure that the quality of the movement and the expressions is good, and then look at how people in VR react to that and how they can engage with the characters. Do they feel comfortable or does it feel strange? This is something I think I could easily spend 3 more years working on.
I was pointing. Michael?
I would do more research, obviously. But I mean, it depends maybe partially at least a bit on what kind of research, on what would be the result of the current research. Like if the EEG method works out, I think there's a lot of potential. Then if this works for co-presence, we can test this with different avatars and different presence technologies and assess the impact here. Um, and otherwise, it's also, I don't have specific ideas for what kind of research, but it's always when we do experiments, we can always focus on specific aspects. And having 3 more years, we could look at different aspects. What kind of aspects can we also test? How do haptic gloves, how does holoportation affect presence or other kind of or the VR experience in general? Yeah.
Okay. Iris?
It's a very good question. Of course, I mean, involving users in the further technological development would definitely be interesting, and I think that's a never-ending task, which is nice. But in terms of using the money to innovate our methodologies, I think I would look into using AI in those first ideation sessions to maybe see how we can further develop other use cases, how users will or would like to see the technologies, the technological pillars used in different circumstances. But to really use the money to experiment with how we can use AI for that, and how we can use AI to enhance their understanding of technology in those first phases, which has proven a bit difficult sometimes.
Thanks. And Anna, another 3 years?
Well, I agree with Mireille in general that we could do a lot more explanation. One thing I would love to do is actually have a real world comparison. So do the same EEG experiment, but in real life, and then you could really compare. You'd have a fair comparison and say, okay, we're looking the differences that you would find. I think you would still find differences between in the signal. That I think, and also, yeah, we are working on the eye tracking version of it, so I think that's going to be feasible within the project as well. But yeah, research is never ending, so we could find a million things to test with the EEG experiment. Even with just that one experiment, we could change different parameters and see how that would play out in the brain, basically. Yeah.
Okay. And then Sergi, apart from another 3 years, there's also a question for you. Is there a plan to be able to implement this within existing volumetric capture studio pipeline, such as 4D views, for example? So the challenges and that question.
No, there is no such a plan because the project will end in 9 months, and 4D view should be part of the project. It's definitely very interesting, although 4D views, I don't know if they do real-time capture, but I'm sure they have such a solution for real-time, even if the quality is not the quality that they get with offline processing. And not only 4D views. Actually, there are many volumetric companies out there. They are addressing the offline scenario because, of course, you have more time, and then the quality and the processing to put on it is much more. And actually, the business, we see that the business today is more on gaming experiences, but with pre-recorded content. And there is a big stopper everyone knows for real-time human-to-human group experiences, for what Michael always says, this bulky thing in your head. Although we are sure this is going to improve. Now we have an opportunity for Europe, actually, since it looks like the American companies are lacking in that sense. But the European Union is still willing to have a full European headset, thinner, and eventually this will happen. And I don't know how much time it will take. My guess is
Sergi?
that
Sergi, we can hardly hear you. There are other voices.
sorry,
Is it because there are other voices behind?
there are other voices everywhere, even in my head. I'm going to
Other
change.
than yours.
Yeah,
Thank you, Sergi.
basically. Yeah, what I was saying. I don't know what I was saying. In any case, next 3 years. The question was opportunities for the next 3 years, right?
Yeah.
Or challenges for the next 3 years. For us, the next challenge is, well, first for this year to have a TSDF version that really gets a quality closer to, for instance, what you can see in 4D views webpage. And the next big step will be Gaussian splatting reconstruction close to real time. This is going to be extremely difficult. But even before that, we would need real-time compression and transmission of Gaussian splitting. Now, we don't know, actually, we don't know if this is the definitive format for volumetric video. To be honest, I don't know, because there are other solutions that look pretty good and they are not that smart. They are more, let's say, simple solutions, more engineering solutions than mathematical solutions. We will see. So that's for me what is going to happen in the next 3 years.
Thanks
Which
very
one?
much.
Welcome.
Thank you. This will be my last question, and if there's no further discussion, we can end after this, which is I want you to address this now to people who've never been in a European project. So can you give some idea of your experience of working in a European project on a complex task like this? How was it working in the project? What are the good things of it? What are the bad things of it? Just kind of your feeling about working in a European project that will help others to manage their expectations about working in such a project. Joanne.
So I think one of the nice things about the European project is that it brings an opportunity to follow for a longer time what other teams are doing, and it brings up opportunities for collaboration because often I mean, European projects are not set up at random. The people that are involved in a project are carefully chosen. Sometimes you know them before the project, sometimes not, but it's a very good opportunity to develop a longer relation, develop collaborations that generate things that alone you could not do, and speak for a longer period about ongoing work so you get new ideas and yeah, I think it's a nice way to collaborate and to basically build things together. Sometimes there's more opportunities because there's more affinity on the topics and on the methodology, and sometimes not, but it's also interesting to see what other people are doing.
Michael.
Okay, let me first start maybe with a not negative, but at first it was overwhelming. Like I started in the project when it was already running for almost a year, and I got then access to a Google Drive folder with tons of documents, and people talked about KPIs where I didn't know what it means, and this was quite overwhelming because I never worked in such a big project. It was usually that I worked on something and there was maybe one more person working on this project where I was working on, but that's it. And here suddenly we have 17 partners. I don't know how many people are involved, but it's really, really huge. Um, and this was sometimes a bit, especially in the beginning, a bit exhausting. But otherwise, I can fully agree with Joan. It gives a lot of opportunities for collaboration. Like we have one project where we collaborate with i2cut, with people from there for to test holoportation. We have another project where we work with Joan and also with researchers from Hamburg to test intelligent virtual agents. And you get to come in contact with a lot of people in the field, which is pretty nice. Um, yeah, this is basically.
Okay, thanks. Iris.
Yeah, I agree that it's really nice to see what other people are doing. As a user researcher, for me personally, it's also a lot of fun to, I don't have to be technically literate, but I do get to play with all of the things that are developed. I get to try the haptic gloves. I get to try all of the experiences, and then I can comment on it without having to know technically every little detail about how it works or so for me it's the fun part is in that within the people you meet, everyone has its role, and you really once like the beginning is hard. I agree with Mikael there. The beginning is always hard. You don't know the other partners very well, but once you've met up a couple of times and things are evolving, for me, it's really nice to see the synergy that comes out of it and how everybody contributes little pieces to understanding the complexity of the innovations that we work on.
Thank you. Anna. Have you ever worked in a European project before?
No, I had not. Not it's certainly not of this magnitude. So yeah, for me it was very new working with I'd never worked with companies before either. So we usually work with researchers. So it's definitely different mindsets, different ways of working, different goals. I mean, yeah, I never really thought of things in terms of user cases, just always thought of participants and participants' experiences, which I mean in the end is very similar, but in the beginning, it was quite overwhelming. Also, a lot of online meetings, a lot of organization. Of course, you have all these people together, so it takes a lot of organization. I thought that actually what helped a lot was having the in-person meetings. There's something about, which is a bit ironic being in a VR study, but there's something about being in the physical presence with other people that all makes it makes more sense at that point when you can really exchange and see people present. Oh, he's the one doing that. Okay. Oh, these are the avatars. It kind of thinks so I think those meetings are actually quite important. Not all the time, but the number that we had, I think was perfect. Yeah, I would say that you meet a lot of people you never would meet otherwise and different ways of working that you learn from necessarily for sure. Yeah.
Okay, thanks. And Sergio, you can give the coordinator's perspective on this.
Uh, what was the question exactly?
About what, for people who've never been in a European project, what's your experience? What would you impart to them about the positive, even negative aspects of a European project?
Ah, let's say the negative aspects, because that's the easy one, comes with the fact that a lot of different people from different institutions with different objectives are together. I've played the role of coordination more than once, and this is always difficult for you as a person and for the team, of course. But it's nice to see. It is nice that you have like 2, 3 years to make things work. So you see at the beginning like a lot of clash. It's always the same. First 6 months, first years, like very crazy, and then you see that people start to understand each other, and then in the end of the project, you really have a really good performing team that you could do really big things. But then you are finishing the project. And of course, independently, every team has done what they wanted to do, or they to some extent achieve their goals. Um, but it would be nice to try to. Sorry, do you hear them? Sorry, it would be nice to accelerate somehow this landing process. And I don't know, maybe for the next project we should do like a 2 weeks a meeting uh, together, and you do now we do meetings every 6 months, but if you spend like 1 week together, then you go back 2 weeks home, and then 1 week more together, you may accelerate all this process. It's an experiment we never did, and it's human collaboration. So
Very
and for
interesting.
yeah,
You bring all the families as well, so can have a huge meeting with all the families and children and everyone together. Yeah, great. Okay, so can anyone answer? Does anyone know anything about quantum computing? Because Nat asks, I guess quantum computing will quickly accelerate the real-time possibilities in the future. Is anyone able to comment on that?
and graphene, both things. When we have quantum computing and graphene, uh, everything is going to be
What's graphene?
grapheno. How you say grapheno
Oh,
in
graphene. Yeah,
graphene?
okay. Yeah.
I don't know. I don't know. This is still too far for me in my let's say roadmap. But
Anyone else?
So I have to say I also basically don't understand anything about quantum computing, but what I always hear is that it's not will not replace a classical computer. It's more for specific tasks like encryption and stuff like that, where they are really good. But for normal computing and real-time rendering, to my understanding, they will not be helpful. They will be breakthroughs somewhere else. But like I said, I'm not an expert here. This is just really superficial knowledge.
Right. My understanding is the same as yours in this respect. Okay, so thanks everyone. I just want to end by saying that, okay, we finished now this series of webinars from the Presence Project, And the follow-up is going to be that there'll be a call from Frontiers in Virtual Reality for submissions to a research topic around the themes of this project. Of course, members of the consortium can submit papers to this, but so also can anybody else who contributes to this area. So having said that, I think we can close the meeting just exactly on time. And thanks everyone for participating, and thanks to the attendees for coming. Thank you. Bye-bye.
Thanks very much.
Thank
Thank
you.
you, everyone.
Thank you all.
Bye.